Today I am going to explain some important words related to chemistry. First is matter. What is matter? So, matter is something that occupies space, possesses mass, and offers resistance to any stress. Okay? In the simple way, we can say that anything which has mass and occupies space is called matter. Yeah, we have been studying it uh, from uh, from six onward. It is, isn't it here? So that is matter, which has a mass and occupies space. That is matter. Second, substance. Yes, this is important. Substance. So a kind of matter that cannot be separated into another kind of matter by any physical process is called substance. Means substance is a pure thing that is made up of only one kind of matter. So okay, you cannot separate a substance into another form of matter by any physical means. So okay, for example, you can say water. Water is a substance, you can say. Calcium carbonate, it is a substance. Sodium chloride, it is a substance. But if we mix sodium chloride into water, that become mixture. That doesn't, okay, this is not a substance. It becomes a mixture, right? So substance is a pure thing. It is pure thing, right? Now, yes. So substance is a pure thing. Now, next is the pure substance itself. A sample of matter containing only one kind of substance is called pure substance. Yes, pure substance it is. So it contains only one kind of matter, not two kind. If we mix, suppose, sodium chloride into calcium carbonate, so that is no longer a pure substance. That become a mixture, or isn't it here? Now, mixture. A mixture is that form of matter in which two or more substances are simply mixed in any proportion. Yes, in any proportion, if it means. Suppose we are mixing salt and sugar, sand and salt, water and sugar. It is a mixture. So mixture has no fixed, okay, proportion of the constituent substance present. Okay, you can put okay, in 100 ml of water you can put any amount of sugar. So that is a mixture. It is not fixed. The constituents don't have the fixed ratio or proportion, right? Now, solution. Yes, a homogeneous mixture of two or more substances is called a solution. Homogeneous mixture. What is homogeneous? Homogeneous means thoroughly mixed up. Thoroughly mixed up. Suppose if you have made a mixture of water and salt, okay, mix it up together, stir it and mix salt completely into the water. If you okay, if you take mixture from anywhere or the beaker, that will taste salty. In any portion of the beaker, if you taste, okay, it will taste salty equally, not more or less. Not at this person it is tasting salty more, or that person salty more, it is, so means the salt has been mixed into water thoroughly, entirely, it is, so that is a solution. Acha, more about solution. A substance which is dissolved is called solute, whereas the substance in which the solute is dissolved is called solution. It is called solvent. Solvent it is known as. So solution is equal to solute plus solvent. Solute is equal to solution is equal to solute plus solvent. Now, a solution in any solvent can, other than water, is called non-aqueous solution. Yes, non-aqueous solution. Okay, non-aqueous means having no water. Aqueous means having water. Okay, a solution which contains no water is called non-aqueous solution. Non-aqueous. Okay, what can be the example? Example can be, if you um, if you dissolve a rubber into kerosene oil. Okay, this rubber eraser, eraser you to have it. Okay, you used to rub pencil marks, so that makes a solution. Okay, so eraser can be dissolved in kerosene, so that is non-aqueous solution. Okay, like alcoholic drinks, like brandy, means they contain no water, they contain alcohol plus something else, so that is a non-aqueous solution. Okay, as a homogeneous mixture is a solvent. A homogeneous mixture of a solvent and a solute in which the size of the solute particle is about 10 to the power minus 10 meter is called a true solution. Yes. When the size of the solute is 10 to the power minus 10 meter, 10 to the power minus 10 meter. Now, suspension. What is suspension? Heterogeneous mixture. It is a heterogeneous mixture in which the size of solute particle is larger than 10 to the power minus 7 meter and are visible by naked eyes. It's called suspension. Usually these cups, syrups are suspension. The doctor advice is to just shake the bottle and you take the medicine. Why? Because suspensions, the particles are more than 10 to the power sedimentation. The process in which the suspended impurities in a solution settle down under the action of gravity is called sedimentation. Yes, suppose in case of dirty water which contains mud particles, if you keep it for some time, the particles will settle down. Okay, and you will see the clear water at the top, so that is called the sedimentation. Right? Now colloid, very important. Colloid, it is a homogeneous looking heterogeneous mixture. Yeah, my god, it is homogeneous looking heterogeneous mixture. It looks homogeneous but it is heterogeneous. Right? Looks homogeneous but it is heterogeneous mixture in which the size of the solid particle is between 10 to the power minus 9 and 10 to the power minus 7 meter. Okay, so colloidal is a heterogeneous mixture but looks homogeneous, and the particles size of the particle is between 10 to the power minus 9 and 10 to the power minus 7 meter. Examples you can have this milk, blood, office paste, we have gum, we have the office paste, it is a paste. So they are the colloidal solution. Now, what is Brownian movement? The zigzag movement of a colloidal particle and the suspension in a solution is called Brownian movement. Brownian movement, you can see Brownian movement, at home also you can see. Just take a small piece of camphor, and just drop it, in a glass of water. Okay, so you'll see the camphor will be just moving in a zigzag manner. It is here. Okay, see that the water is a bit warm. It is here, not boiled, not very hot. It is a bit warm. If we place a camphor, small piece of camphor in warm water, the camphor will be moving like this. It is here, and that is a Brownian movement. So zigzag motion. You can one more example can be the movement of football in a field, football ground, isn't it here? The balls are kicked here and there, there and there. It's like this. So that is a Brownian movement. Then Tyndall effect. Scattering of light by the colloidal particles present in a colloid is called Tyndall effect. Yes. Lights it scattered. Okay. Light it will be scattered like this. It is a scattering. The scattering of light is called Tyndall effect. This you can see at home also. Take some water having some starch, rice starch. Okay, water plus rice starch at home in a transparent glass, and just switch on what you call a torch. Switch on a torch. It is, you will see that the light inside the glass having water and starch is visible. That is the scattering. It is here, and it will move like this. It will move like this. It is that light is scattered by this colloidal solution and suspensions also. They scatter the light, but the true solution, okay, light is not scattered in this true solution, never. Light is passing in this way, it will pass straight like this. It is here, and the particles of the true solution will not be visible by the light. When switch on the torch, it will not be visible. Now electrophoresis. What is electrophoresis? The movement of colloidal particles under the influence of electric field is called electrophoresis. Okay, electrophoresis. The movement of colloidal particles under the influence of electric field. Movement of colloidal particle under the influence of electric field is called electrophoresis. Electric field, this when a current is passing, so that has an electric field. The same way magnet has a magnetic field. Okay. So movement, when it will bring a colloidal solution, okay, close to this electric field where the current is passing, will find some movement in the particles of this colloidal solution, and that is known as electrophoresis. Okay, now physical and chemical change, very well it is here. So physical change is that change in which no new substances is formed, and it is temporary change. It is reversible. Okay, physical change is reversible and may also not be reversible. For example, suppose if you tear a page into small pieces, you cannot make it one sheet once again. So that is it may be reversible or may not be reversible, but chemical change is always irreversible. Right. So during a physical change, only the physical properties such as physical form, color, shape, etc. undergo a change. Nothing else. Only physical things undergo change. Okay, like shape, color, they change what is here. Chemical change is that change in which only new substance is formed, and the properties of the compound is completely different from its constituent element. For example, water. Water is formed by the combination of hydrogen and oxygen. But hydrogen burns itself, and oxygen helps burning. But what does the water do? It extinguishes fire. Look at the water, which is made up of inflammable and supporter of inflammable, put of fire. isn't it here? So the property of water is completely different from hydrogen and oxygen. So this is so very new substance is found here. So chemical changes are always irreversible, and this is all about. Next time I will do something more. It's okay.